Hi everyone, welcome to RPI Data Science. So up to now, we have tuned models, support vector machine models, mainly radial SVM, linear SVM, and sigmoid SVM. We have also seen support vector machines from quantita text models package, but earlier we have also seen naive bias from again from quantita text models. In the last video, we have seen tuning support vector machines using the sigmoid kernel. So up to now, I mean, when we were developing training our models, we have seen some of our models take a bit of time. So let's say one of our model here. This is a sigmoid. It took roughly more than 7 minutes, and then the second one with DFIDF took us more than 9 minutes. So there was another model, especially the radial SVN. It took a little bit longer. So maybe you may run a model that may take like hours or maybe days or something. Then then you don't want to rerun. Let's say you run your model and then your computer crashes or suddenly power button goes off or something. Then you don't want to rerun for it. Let's say we have gone a long way. So if you remember, we started from loading our libraries. Then we have text preprocessing. And then we have also some text classification using all these models. So so every time when we restart our PC, we don't have to rerun all of this because it's really time consuming. So we don't have to rerun. You will lose a lot of time. But what you can do is you can save your models. You can save your models and then load them whenever you need to. For that, what you need is this save image function. So the save image function, what the save image does, this is really life-saving, especially if you are running a model that's more complicated and it's time-taking. Let's say if you are running like Bootstrap or something, or maybe deep learning, any kind of model that takes longer time, and you don't want to rerun it. So for that, you need this function, save image, and then what you're gonna do is, let's say you can really typically save an object, just one object, or you can save the entire workflow. So if we see, let's say with ls, so I have already many objects. So these are all objects. I mean, if you are in RStudio, you can also see it on your environment pane. In RStudio there is this environment, and then the code editor button, and then there is a code the button. I mean the piece or the part that you mainly see your results. So on the environment pane you have your objects or the functions that you have already created. So with that, with the Jupyter Notebook, because I don't have the environment pane, if I want to print all my objects, this is a function that I need, ls, or I can also use objects. So I can see this like this. I can print them. So these are all objects, and some of them are really they have taken more time. So for that, what I need is this save image function, and the save image function what it does is like it saves the mirror image of what we have done in here from the beginning until now. So every time you run this kind of complicated model, you always have to rerun this save image, and then you give it a name. Let's say I would like to save the entire script and all the models that have been already trained, and I just want to save it. And then once I save, at the beginning of my my analysis, I simply load it with a load function. Load. Let's say if I save it using my analysis, I will save the entire data analysis like this, and then the extension is rdata. So you can use rdata. That's the extension. And then whenever you want to, you can simply load this. So you load this, and then you can rerun everything again. But I mean, you don't want to rerun, so you just can continue from where you stopped. So you can save image, and then after that load, and then you can simply start from where you stopped. So that's what I have done already. So I have last time after I complete the video, I don't want to rerun the whole thing again. So I have already used the save image function, and today I came at the beginning of, the way I saved it is actually here. So I have saved it here, save image, COVID, SARS, classification, data, and then today I simply came here at the very beginning of my tutorial. So I load everything that I have already created, and then I can simply scroll down and start where I stopped. So this is where we stopped last time. I can simply continue from here. So I can simply continue from here. So what I want to do today, so now I have already loaded my other objects. My objects are already there, so I can continue from where I started. So now what I want is I want to extract all the let's say, let me print one of the competence interval confusion matrices that we have done already. So this is one for example, this is confmat, and you see actually this is not what I want. So let's say confmat linear or radial. I think not this one. Linear. No, I have already changed some of the function. So if you remember, there was one function that we have created. So this function was this spreadconf function that, if you remember from my last tutorial, you remember. So this spreadconf function, what it does is like it takes the tuned model, the best parameter model, and then the test data, and then with that it predicts the class, and then after it tabulates the predicted class against the test class, and then from there you can develop your confusion matrix, and that confusion matrix is coming from Karet's confusion matrix, and you create a tabulated class so that you can and then the model will be everything. Then you will have your sensitivity, specificity, and all different values. So let's say let me rerun this, and then I rerun it. So I can see I have two lists of objectives. One is the 2x2 table, or in epidemiology you can call it contingency table, or maybe it's confusion matrix. That's the more machine learning term. But also we also have a printed other object in the list. So that's the other one, conf_mat. That's the confusion matrix. I mean the details of the confusion matrix. So if you see this table, we have already printed it here, and again we are printing it. So I don't have to print this again. So I can simply so I would like to. I just wanted. So I use list. I just want to show that if you write a function that returns the two objects, then you always have to use this list. That's actually what I wanted to say last time, and that's why I use this list to return two different objects from a function. So, but I just, because it's a repetition, I don't have to return two of them. So I just turn off this. So the other one, which was the tabulator class, I just remove this, and then my corporate conf function does its it predicts it, and then after that it gives me my confusion matrix. So now what I need is I need to run this thing, and then I give it a name. So this is from this is from radial. So let me call it conf_mat svm radial radial. Actually, let me just call it radial. I don't want to make it bigger, so let me give it conf_mat radial, and then the next one will be conf_mat radial tf_idea. Then I simply run it, and I save this object, and then the next one again, I simply run threadconf, and simply I can simply type into linear. So this one I call it linear. Actually, yeah, conf_mat linear, and the next one would be conf_mat linear tf_idea. Now I can run again. So I save this prediction or confusion matrix into like linear for conf_mat linear tf_idea, conf_mat linear, and then for the next one was sigmoid, which actually took 7 minutes and 9 minutes. So I can predict my again with predict conf function. So this would be sigmoid. I can call it sigmoid and save this object. The next one sigmoid tf_idea. Let me actually correct it here. Yeah. So then conf_mat sigmoid. The next one will be conf_mat sigmoid tf_idea. And I will run this again. So now I have at least 6 modules. So what I want is I want to create a table. So every time we, comparing, let's say if you want to compare conf_mat linear with conf_mat linear tf_idea, you always have to scroll down this table. I mean this long. Instead, we can kind of create a table, like a table. So the table will have one of the table would have like let's say here would be the models. The models would be written on the side. Models. So the models, and then for the models, let's say linear SVM, and you may have linear SVM, and then linear SVM tf_idea, and so on. And then on the column side, you will have like sensitivity, specificity, accuracy. Then you can easily compare. You can easily compare if you see all of these confusion matrices in just one table. That's what I want to do now. So that's the main goal of my what I want to do, what I would like to do now. So for that, what I need is I need to create a function that extracts the that extracts the values from each tables. I mean, from the confusion matrix, from the details of the confusion matrix. And then once I extract that, what I need is I can simply combine them with rbind or cbind or whatever is appropriate. Well, actually, before that, we need to find out what are actually the contents of confusion matrix. So this is just one of the details of the confusion matrix for the linear SVM. So if you see the first part of this printed object is this 2x2 table, and the second part of this matrix, I mean this detail of the confusion matrix for the linear SVM is this part of the figure. And then again, there is another part on this side. Then again, another one. This is a positive class. So to access the names, to access the parts, what you can do is you can simply call the names function, and then close the bracket, and you print out. So these are the values actually that what we want. So if you want, actually we can again print this, and then we can see the side-by-side comparison. So let me see again. So let's say if you want, so names. Let me turn these names off, and then I can simply use this $sign, and then table, for example, if I want to see the table. So the table would be the first part of this part of confusion matrix that Kite is actually giving us. So then the next one would be actually I want to print that again because I want to access the names. Names again. Turn this, okay, and then overall, the overall would be this accuracy and kappa and the like. So it's the accuracy, kappa, accuracy, confidence interval, like lower and the upper part of the confidence interval, and then the p-value and the test for the accuracy p-value. That's the overall. And then if you want by class, the by class would be the details, more sensitivity, specificity, and the like. So this would be by class, and then the mod will be everything because we have already chosen everything. And I mean, when we create our confusion matrix, we decided to assign the mod to be everything because we wanted to print everything. Actually, I can scroll up and show you from our so this is the mod. So this is the mod, is everything. That's why we have that everything in our in the names for the confusion matrix object. Yeah, so these are everything. And mod, I mean dots, we haven't assigned any dots. In fact, I have never used it, so there will not be anything related to this to this variable, to this name. So what I would like to tell you is like if you want to access, let's say if you want to access this object, this one here, so this one will be like the row is 1 and then the column will be 2. Let's say if you create something like this, so 1 would be this value. I suppose it's this value. Yeah, so this will be the value. So that's what we want, because I want to, I want to print everything. So for each, because I want to extract each value. So that's why 1 1. So this will be column 1, row 1, and column 1, row 2. Row 1, column. The first part is row, and the second one is column. So 1 2 would be this 10. That's so it will be 10. And then if you say 2 2, then that means it's 131. So that means this one is true positive. That's true positive value, and this is a true negative value, and this one is a false positive, and this one is false negative. So this one now, sorry, this because this is a projection, so here is a projection, and these are the actual values. So if COVID, our prediction is telling 153 COVID cases, so that means 10 of them are false positive and 10 of them are false negative. In fact, while they are actually COVID, our prediction is telling they are SARS, so they are false negative because our positive class is COVID. So when we want to calculate sensitivity, specificity, and the like, we need to extract these values. Let's say if we want to calculate confidence interval from sensitivity or specificity, we need these values. We need these values besides sensitivity and specificity for confidence intervals for each corresponding to each one. So let me create one function, and let me call that function extract function. Then let me what that function takes is function. This is the usual way when I write a function. So this function takes confusion matrix. It takes simply confusion matrix, and then it doesn't take anything else. Actually, you can we do something else. We can also add something, but let's say for this moment this function takes only confusion matrix, and then from there let's extract some of the values. So x would be, let me assign x value, and let me just arbitrarily find an x. This is not actually what I want. This is a curly braces that I want actually. So then let me move this x value here, and this so if you remember confusion matrix by class, so let me say by class. So when you print these values, they are really boring. So there are many significant digits, and let me actually round all these values, and let me simply take this, and then what I can is round, actually not conf, not linear. I need to take this one, and this function goes into confusion matrix by class, and then it rounds first. It rounds it into 2. So let me say if you round, so you actually round this, not actually to 2. I would like to print it to 3. That's I think the usual way you report in your papers. So you report 93.5, 90 something. If you multiply by 100%, so it would be more sensible to report it like that instead of like 93% or 94% or something like that. So this would be more. It will be better to report it as into 3 significant digits. So now I approximate it, so like it by 3, and then the next thing will be I need to create like names corresponding to x. So the first one would be, let me create accuracy. So let me just create accuracy because I want to extract the accuracy. So to extract accuracy, if you remember, accuracy is where overall is. Let me just take this overall and then see where accuracy is. So this is where accuracy is, which means it is at the first point. So this will be this is a list. It's a list. So the list would be at the first point. So if I simply use this, and maybe if I actually print if I print like this, and then simply point like this, so I will have to extract accuracy. So if you say the first point, that will be accuracy. But if you say 2 again, second point, that will be kappa. So that's how you access the values for using this confusion matrix. So now what I can is I want to extract accuracy. So now I can round it again. I take the confusion matrix, the conf mat from here, I can simply copy and replace it. So overall, but it's at the first position. That's my accuracy. It's at the first position. Now I get my accuracy. The second thing would be I want to extract the true negative, the false negative, x later, x false negative, and x true positive. Let me start with false positive, and then true positive. After that, I can create x total. Especially if you want to, if I want to calculate something, I can also create the total. And now I need to create the values, identify the values where they are. So let me take this. Actually, I can come back to that, but let me just do it like this. And then for each, actually, I can do rounding. Actually, I am rounding already, so x true negative would not need any rounding. So if you again, what I need is a table. So conf mat table, because if you want to extract the true positive, true negative, and false positive value, what you need is a table. So let me again print this. So the false positive, the true positive will be this value. So that means conf mat 1 1. So that will be my true positive value. And if you want a true negative value, that would be here, the true negative, and the false positive is this one, and the false negative is here. So it's 1 3. This is 1 1. This is 1 2. This would be 2 2, and this would be 2 1. Actually, sorry, 2 1, and this would be 2 2. Second is the column, and the first is the row in your table. So then this would be confusion matrix. Again, table. So table. For each one, actually, let me take this here. And total would be the summation of all of these. So xtn plus xtn plus x fpx, all of them. We have to add all of them, and then we get the table. But for this, actually, I don't have to print this twice. So true negative. Where is true negative? True negative is here. So that means it is my true negative would be COVID. Yeah, true negative would be 2 2. True negative. That is, you need to be very careful, otherwise you will mess it up. But we can also see here, if you want, if the true negative, because true negative is at like 2 2. So if you want, you can print this 2 2. It should be 131. So 131. So that will be our true negative, and the false positive will be false negative, actually, because we want to see the false true negative already, and the next one in our list is false negative. So that will be false negative value would be this one, this 10, which means 2 1. The row is the second position, and the column is at the first position. So that means it's 2 1. So that's our false negative value, and the true positive value would be, I mean, the false positive value would be somewhere at 1 2. That's this position. So at the first row, second column. So that will be our 1 2, and then this true positive would be at 1 1. This position is my true positive value, which means 1 1. So now I have all of the values, and then let me see. Actually, if I can sum of them, sum all, but I don't know. Maybe let me just use the sum function, and then if it is actually totaling them, I don't know. Maybe it's possible. Yeah, it's possible. So I can use the sum function, and I can simply print them. Yeah. So this is 294. So instead, I can use sum function and then the conf table. So I can use sum instead of adding, like instead of putting it like xtn plus xfn plus xfp plus xtp, I can simply use this function, can take sum of confusion matrix, and it takes the sum of the sum of the table. And finally, my function should return x. That's what I need. So let me run this, and then let me apply this function to my to one of my confusion matrices. So if I want to apply this, I can simply pass extract function, extract, because it's extraction, and then let me simply call one of my confusion matrix, let's say complement linear. So now it has already extracted all the values that I want. So it has even a total, true positive, and they are all listed, and what I want is already printed. So what I want is I can run for each this function, then finally I can put them, as it means this is a list, I can concatenate them, and then after concatenating I can also bind them using rbind, possibly, I don't know, maybe cbind, we'll see. And then finally you can have your elegant table in your, yeah. But before that, actually I would also like to calculate, because we already have accuracy. I'm not sure we need a confidence interval for accuracy, but I'm more interested on just showing you how to calculate confidence intervals for sensitivity and specificity. There is this formula. This is from the from I don't know this. I forgot the name of this U.S. Institute for Quality Evidence Synthesis. Actually, it's mainly on agency for healthcare research. This is a kind of high impact serious book. So they do reviews, and so it is a high impact company. I mean, high impact research institute. So they have many papers, many methodological guidelines, and things like that. So this is one of their confidence interval formula for sensitivity and specificity. So what if you want to calculate 95% confidence interval, it's like for sensitivity, you take the sensitivity plus or minus, and then 1.96 times the standard error of the sensitivity. And so what you need is the standard error of sensitivity. How do you calculate the standard error of the sensitivity? They have already provided the formula. So what you can is square root of sensitivity minus 1 minus sensitivity divided by the total number that you require for sensitivity. So to calculate sensitivity, you would need true positive plus false negative. So that's what you need: true positive plus false negative. So they will be in this part. The rest is just sensitivity and sensitivity. So that will be the same. Again, for specificity, you just need to replace this by true negative plus false positive, and then the rest will be done by your confidence interval formula. Yeah. So now I want to create another formula, and that means confidence interval for sensitivity and confidence interval for specificity. Let me just create conf int sense, and then another function will be conf int specificity, and then I can simply create a function. Then that function will take again the conf mat. Again, I'm making this error. I want a curly brace, but I'm calling this square brackets. So again, for this one, I simply call my function first, and then my my curly braces, and then from there my function takes again confusion matrix. That's what it takes. I can simply take it the same way as I did it in the previous one, or you can simply call it or X or something, but let me just call it confusion matrix function. So now let me just bring that. Let me extract the data values. Actually, okay, by class, maybe by class. So by class, I take the by class, from the confusion matrix. There is this section called by class. So for that, what I need is I need the conf math. Actually, this one confusion matrix, so not conf math instead. So for that, conf math by class. Yeah, there you go, by class, and then I can simply make it a data frame. So then it will be easier to access the values. And then let me check again sensitivity. Let me just sensitivity. Sensitivity would be by class. By class at the first position. Actually, let me check how this actually by class. Let me just again print this one, and then let me show you. So that if you want, so this is the by class. The by class will be at the first position. So if you want, you can kind of print the first position and you get the sensitivity. But if you make it a data frame, so let's see how. Actually, we don't need to even make it a data. Make it a data frame, and instead we can simply give. The value at the first position, so that will be sensitivity. So we don't need actually this, but if we make it data frame, it could also be something easier. So instead, let me just also access it like that as data frame. We can just try another possibility using a data frame. So this will be how, if we make it a data frame, this will be how it looks like. So sensitivity would be where at the 1-1 position. So 1-1 position, specificity is at 2-1 position, and positive predictive values at the 3-1 position, and then it goes like that. Yeah, so we can keep the data frame part, and then sensitivity, as I said, will be on 1. Actually 1-1. So if you let me just check if this one would be. Let me call this C, and then see what C11 actually means. You know, these things are like trial and error, so I would like to access this value. So C11 means, yeah, so C11 means 93.5, which is a sensitivity value. So then I'm right, but what if I use C1? That means it will be the name of, so simply it will be sensitivity. So actually it will simply print all the rows. Yeah, actually that's also fine, C1, it's interesting. Yeah, so it can also be simply 1 or 1-1, it doesn't matter, but let me use it more descriptive name. I prefer not to make any error. Then true positive, because we have already get the true positive value. So what we need is a true positive would be here, true positive, and then let me just call this. And then what I need is the false negative value, because I am calculating confidence interval for the sensitivity. So the next one I need is true positive plus actually true positive plus false negative. These are the values that I need. Oh, I need to make sure that I don't make any error. Actually, it's not like that. Yeah, so the confusion matrix table 1-1 is actually my true positive, where the true positive is. This is where the true positive is, and then the false negative is here. So that means it's second position and second row, first column. So now the next thing I want to do is the lower and the upper confidence interval. Let me call this lower. Then the next one, let me call it upper. And then let me create this formula here. So the formula tells me sensitivity plus 1 plus or minus 1.96 sensitivity. So that's what it tells me. So let me just copy this and replace that actually. So sensitivity, I have already created sensitivity here. Let me call this. I'm creating the lower part, so that will be subtraction, and then yeah. So this will be what was it? So SC standard error of sensitivity. Let me check the standard error of sensitivity. This is a standard error of sensitivity. So you can simply again pass it here. Then we will replace things. This is how the sensitivity is calculated. So then the square root will stay the same. So you simply call your square root function square root, and then square root times sensitivity. Actually, this would be sensitivity times, let me call this sens. Actually, that's how I call it. And this will be again sensitivity, but this one will be the total of the two, and that will be true positive plus false positive. True positive plus false negative. Actually, sorry, it's not. We are not calculating predictive value positive, so this would be true positive plus false positive. But let me make sure that this works. So R doesn't like brackets for multiplication, so I'm using this rather multiply sign, and maybe I can add a bracket here, and then let me make sure how the brackets are written. And this will be sensitivity sens square root. So 1.96 sensitivity minus 1.96 times square root of sensitivity minus 1.19 sensitivity, and this will be, and then divided by the whole thing should be this 1.96 times square root of. We'll make sure whether actually this like the sensitivity upper and lower confidence interval values include the calculated value. Otherwise, if it is out of range, then our formula is wrong. So that's how we can also make sure. So let me make sure here 1.96 times square root of sensitivity minus 1 minus sensitivity. Sensitivity minus 1. That seems longer. No, this should be multiplication. No, I think I. Yeah, sorry. Square root of sensitivity minus 1 minus sensitivity. Yeah, then the confidence interval will be square root of specificity minus 1 minus. Yeah. So sensitivity times 1 minus sensitivity divided by 2 positive plus false negative. Let me make sure how these brackets are written, and then again. Well, so we are fine. Now the next thing is I need to do this side. This will be the upper, so I'm using the plus sign. I think there is also possibilities that you can use like minus 1, 1. Yeah, I'm not sure. I just don't remember how you can. Yeah, you can write that code, but just forgot something. And then after that, so let me convent sensitivity will be. Let me do something because I want to paste confidence intervals, so let me just use this paste function, and then within that, let me use it for the upper part, let me use this bracket sign, and then for the second one, whatever it is, I want to round the values that I have already calculated. So this will be the lower, and then I want to round it to 2 significant digits, actually 3, and then again, let me create a separator because I want my confidence interval to appear like this, like for example 0.95 up to 0.99. So they need to appear something like this. So for that I need a separator like this. Then I need all these values, the square brackets. So I'm using this square bracket and a separator. Then finally I need another one round for the upper. Let me just copy this, and then the next is upper, and then I need another one for the to close the square bracket. Let me close this square bracket and instead change this to closing sum. Now my function should return my confidence interval. So that's how the whole thing is to calculate confidence interval for sensitivity. So return, what am I returning? Confidence sensitivity. Yeah. So that's how I calculate sensitivity. But I can implement this function and see how it works. So let me run it again and see if actually it works very well. So let me just see conf.mat. Actually, let me just call conf.mat linear and see. So there seems to be I seem to have made one error at line 19, so somewhere around here. So paste, and then I round lower 2. I add a separator, comma, then round, and then okay, this is where I made a mistake. So it should be upper instead. So my upper. Now if I run this, it should be, yeah, so now it has already extracted the confidence interval values. But we can also print this one. How much was it actually, the confidence, the sensitivity value for, so it's, let me print this again and check whether these values are actually within our range. Otherwise, we can say we might have made a mistake or something. So that's 93.46, and this is well in our interval. But I think, yeah, you need to make sure that your formula is actually right. Yeah. So the next thing I want to do is confidence interval for specificity. So I will just change a few things, and then yeah, conf.mat. So confusion matrix by class. So the sensitivity would be somewhere. So let me just print C. That's actually accuracy. So that will be the second one. So the second one. So that will be C21. Let's say this is the value that I want to print. So C21 would be 92.9. So that's the value that I need. So for that, I need to make sure that let me call this a specificity first, and the rest will be the same again here. This one I will change it to 2.1, and then what I need for the sensitivity is true negative, and false positive value. That's actually what I need for the specificity. So true negative, and then false positive. And let me see, true negative is where actually true negative is at the second position, second row, and second column, and false positive is somewhere first position, second column. That's a false positive. If you remember, let me just print this. So this is our false positive. So that will be first position and first row and second column, and this will be second column and second row, second column. This one is first row, second column. Yeah, so that's how you access this value. So we already have true negative and false positive value. After that, you just need to make sure that you have changed these values specificity, and then this is again specificity. Once after that, true negative plus false positive, and then this one will also be true negative plus false positive. Actually, we can simply copy this value and then change it to plus instead of minus. So this Jupyter notebook is, yeah, so there's plus. That's what I need, and then I call this conf-int specificity instead. So let me call this specificity, and then let me print this value here again. That I have to change. I don't have to change actually. So round paste. That's all. That's all what I need. So now I have a confidence interval function for the sensitivity, and then I extracted all these relevant values, and then after that I can simply run for each and then combine it with upper bind, and then I will have I will extract everything that I need to make it a table. Yep. So now let me just do a few things. So for the first one, let me say SVM linear. Let me, I think because I'm using a table, because otherwise we are creating so many objects, we may have a problem. Actually, let me call it linear SVM instead. Linear SVM, linear SVM, IDF. Then I can simply apply my functions, the functions that I created. So the first one is extract function. What was it? Extract. Forgot the name of the function that we created just after. So this is extract function here. So I can simply call this function and then return the confusion matrix for the linear SVM, and then conf linear. The next one would be for the TF-IDF. So I can simply call this, copy this, and then make this into TF-IDF. And again, I do the same for linear. I mean for radial, for example, radial, because I have used more or less the same value. Radial SVM TF-IDF. Actually, this one is L, and then this one would be radial, and this one would be conf math radial is TF-IDF. Then after that, what you can do is you can simply combine them, yeah, bind or something. So you can let me just show you quickly. Yeah, so this is just an ignorable error. So let me just use bind, and then for the linear SVM, let me call this linear SVM, because I don't want to make an error for the raw names. And then again, linear SVM. If I do this, so I will have the values that I need in a table. So this will be, I mean, you still need to do a little bit of manipulating, but this is how you can extract. You can extract the functions. But I can also extract the confidence interval values. For example, CI for linear SVM, maybe sensitivity. Maybe let me call this sensitivity. Then conf-int. Actually, that's not. Let me just copy this and then bring the function earlier that I created for sensitivity, confidence interval for sensitivity, and then you can restructure the values. So now we already have that, and then let me just create again another bind. CI linear SVM. Let me just. Okay. This will not help us because actually I first need to bind the confidence interval values and then again to combine them. Let me actually first combine these values. Let me just remove this. And radial SVM, so for radial we already have that. And again for what we need is for the sigmoid. Sigmoid. And let me just call this one sigmoid SVM TF-IDF. And again here what I need is sigmoid, because this is how I name them, I think. So conf math. There seems to be okay. Let me go back to my sigmoid, and then we can identify how we named our. Yeah, okay, conf math. Okay, there is no hyphen. Okay, where am I? There, yeah. Okay. So this would be conf math, and then this again will be like this. Now I can simply bind all of them and simply call all of this because I just want to print these names. Otherwise, they will not be. Probably yes, but I don't know. Maybe let me just see if these names are to actually appear or not. Maybe let me check. Okay, this seems okay. This comma sign, so I don't need to print it. Oh yeah, so I don't need to worry about this. Okay, so I just need to make a bind, and I don't need to assign equal to this labeling, row labeling. So now I need radial SVM, and then sigmoid. Yeah, then I can simply print it out. Yeah, so I can print all of them. So, and then finally you can, you don't have to extract all, I mean, you don't have to take everything, and then you can simply report whatever you want to. And then at the end, we can also add this confidence interval function, and then we can apply, we can include the sensitivity value. So for that, I think what we need is the cbind. Let me a little bit think. Oh yes, so what we need is we can, so we already created linear SVM, so the next thing will be linear SVM. Then what we do is linear SVM, confidence interval for sensitivity. So let me simply create conf int sensitivity. Conf int or CI sensitivity. So this will create a confidence interval for the sensitivity value, and then we can also create confidence interval for specificity value. And then after that, we can simply implement the function that we have created. This what was this function? Confidence interval for sensitivity, for specificity, for example. Let me just do this. Then conf mat linear again. I can simply type. Actually, this one would be sensitivity because it's and then this one would be something for the specificity. Conf int specificity, and then let me do this. I don't want to do for all of them, but once you create linear SVM or the linear SVM TF-IDF, you can simply yeah, I mean, you can simply create for everyone, like for every function, like confidence interval for specificity and sensitivity, and then after that you can simply combine them all. And then at the very end, now we should be able to see confidence interval for the sensitivity. So this is confidence interval for the sensitivity, and then confidence interval for the specificity. But seems it has messed it up because, you know, the first row it has more columns, the second one doesn't have more. So what I can do is I need to yeah, then I need to create more. Otherwise it will mess it up. So let me. So now, to just save time, I have already written the codes for each of them, confidence interval for sigmoid, and then I can simply bind them. Then once you have already created confidence interval and then all the extractions, then you can simply rerun it. Probably there is an easy way. Probably there is, but let me see. There seems to be an error somewhere. Yeah, so this one is wrong, so it's printing it again. And this is what I want instead. So so let me run this. Now it should be able to work. So now we have everything. So we have confidence interval data for specificity and sensitivity, and then you can, you know, you can print this or save it in Excel or something, and then you can report it. Yeah, so that's all what I want to do today. And then after that, as I said, you don't want to rerun everything again. What you can do is you can save image. So next time, whenever I want to reload, I can simply go up and then load this model again. So every object that I created will be loaded. If I close this and then let's say switch off my PC and come back and then simply reload my R data, this R data file, and then I can access every object, and then I can simply continue where I started. So next, what I would like to do is I would like to start the so now we already have the trend support vector machines, and then maybe next one will be more on regularized models like ElasticNet, Reach, and Lasso. These are the things that I would like to continue further on the text mining, actually, because regularized models actually they handle text data very well. At least in my experience, I have seen Lasso and ElasticNet working very well for text data. So so that would be my next goal, and it's really fast. They have I mean, ElasticNet would be a little bit slower, but Reach and Lasso, they are really lightly evolved fast. So because it's from GLMNet, and I heard from one of the authors of the GLMNet package, they were saying GLMNet was written using this Fortran programming language. So that's why it's really fast. So that will be our next stop, and then after that we'll do more. Yeah, we'll advance more. Okay, so for today this is all, and until then, enjoy text analysis and text classification, and keep supporting the channel. Thank you very much.